Alright, so before we move on to the maximum minimums of quadratic functions, let's go ahead and talk about the x-intercepts of a quadratic function. Now the x-intercepts, this is again nothing really new to us. We've done this many times now, and this is simply finding the zeros of the function. So and then we factor / quadratic formula to find zeros, which again are x-intercepts. I'm not even going to bother doing an example of this because we've done this so many times. But what about finding a standard form equation given x-intercepts? Let's look at an example of that. Well, suppose we've been given the x-intercepts of, let's say, -1, 0, and 3, 0. So these are both x-intercepts. Sorry. They've got y values of 0, and so we've got x-intercepts here going. So how would I be able to find the equation of the parabola? Well, we know that 0 has to equal x plus 1 times x minus 3, because that's what the x-intercepts would be. Now this is the zeros of the function, but now I have x plus 1 times x minus 3, so really all we have right now is that f at x is equal to x plus 1 times x minus 3. So the x-intercepts give us the equation right away, x plus 1 times x minus 3. Now, what do we have to do? Well, we need to multiply these out. X squared, and we'd have minus 2x minus 3, because it asked us to put it in standard form. And so, fortunately, this is a 1 here, and so we'd look at again b over 2 quantity squared, which would be -2 over 2 quantity squared, which is going to be just 1. And so we'd have that f at x is equal to x squared minus 2x plus 1 minus 1 minus 3. Because again, if we add 1, we have to subtract it. Put parentheses around that. F at x is equal to x minus 1 quantity squared minus 4. And then we can see from this that the vertex is 1, 4, axis of symmetry is x equals 1. Now let's go ahead, we haven't done this in a while here, let's go ahead and sketch this here. Now, we could sketch this using the base function, or parent function, and transforms, or we could use the points that we already know. And what do I mean by that? Well, the vertex is 1, 4. I'm sorry, it should be 1, -4 here. So it's 1, -4. So 1, then 1, 2, 3, 4. So that's the vertex. And then we also know that it's got an x-intercept of -1 and another x-intercept, of 3. Now we could also figure out the y-intercept pretty quickly. The y-intercept, just looking at this line right here, if you plug x equals 0 in, you get negative 3 for the y-intercept. And because of symmetry, my axis of symmetry, which is this line here, we know that since this point is right here, we can reflect it over to the other side, and we get a point right there. So real quickly, without even using the transformations, I mean, you could use the transformations, it's to the right 1 and down 4, but without using the transformations, I used the x-intercepts, the vertex, and then I used the idea of symmetry here to real quickly be able to get a sketch of this parabola. Alright, so the last thing we want to talk about dealing with quadratic functions here is talking about minimums and maximums. Okay, so minimums and maximums. Well, first off, if we have a general form, which is equal to ax squared plus bx plus c, this is something that is very useful, especially for getting it into the standard form. The vertex x value is equal to negative b over 2a. The vertex y value then is simply f at negative b over 2a. So if we have an ax squared plus bx plus c equation, we can quickly get the standard form by not having to complete the square, but by just knowing that the vertex x value. How do I know that? Well, because when I'm completing the square, that's always going to be what I'm in essence going to be dividing by, or having the b over 2 kind of term squared going on. And that's always going to be the x coordinate for the vertex. Now, if a is greater than 0, f of x has a minimum at the vertex. And if a is less than 0, f of x has a maximum at the vertex. Now, I don't necessarily memorize all of these things like, oh, minimum of a is greater than 0. I always just think of, well, what does the graph look like? And we know that if a is greater than 0, it opens up. So if a is greater than 0, I don't care where it's located on the graph, it's going to look like this. Well, the vertex is down here, clearly that's the minimum. If a is less than 0, we know that means it opens down. Well, vertex is here, which is clearly a maximum. So I don't necessarily remember that, oh, if a is greater than 0, it's a minimum, and if a is less than 0, it's a maximum. I instead just remember what the graph looks like, and then use that graph to tell me, is it a minimum or a maximum? Alright, so let's see though how this could actually help us get something in standard form a little bit quicker. So let's go back to the example we did at the end of the previous video, where we have f of x, I'm just going to go ahead and write it in red, is equal to 3x squared minus 6x plus 4. So we're going to put this in standard form. Now, instead of doing it by completing the square, we're going to do it by finding the vertex. So first off, I'm going to say that a is 3, b is negative 6, and c is equal to 4. So then the x value of the vertex is negative b over 2a. And so the x value is equal to, I said negative, but it didn't draw in there, negative 6 over 2 times 3, which if we do all of that, we get 1. Then I need the y value, but all I do to get the y value is I just evaluate f at 1, which is 3 times 1 squared minus 6 times 1 plus 4, which this would be 3 minus 6 plus 4, which would be minus 1. I paused the video there for a second because I was getting myself confused, and clearly I can't do arithmetic is why I was getting myself confused. 3 minus 6 plus 4 is not minus 1, it's of course plus 1, which is good because then what we have here is that the standard form would be f at x, a is 3, and then my vertex is 1, 1, so it would be x minus 1 quantity squared plus 1, which is exactly what we got when we did the completing the square portion. So let's look at one more quick example like that. So let's look at following here. Let's look at f at x equals negative x squared minus 4x plus 1. And so we're going to find the standard form, just like we did before, but we're going to use the vertex to find that. So we know that my x value is negative b over 2a, and so that would be negative 4 over 2 times negative 1, and if we're careful with all the arithmetic here, negative 4 is positive 4 divided by negative 2, so this would be negative 2. And then the y value is just f at negative 2, which should be negative 2 squared minus 4 times negative 2 plus 1. So this would be negative 4 plus 8 plus 1, which would be 5. So then the standard form here would be f at x is equal to, I'd have a negative 1, so negative x, and this would be plus 2 quantity squared plus 5.